Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture, and in this video lecture we will study Newton's forward difference formula and we'll prove it. We'll do its proof. So that proof is very important from examination point of view. So let us suppose let fx be a function that assumes values f of a, f of a plus h, f of a plus 2h, f of a plus 3h, and so on up to f of a plus nh at points x is equal to a plus h, a plus 2h, a plus 3h, and so on a plus nh respectively. So we assume a function fx. Let us suppose a function fx that assumes values f of a at x is equal to a, f of a plus h at a plus h, f of a plus 2h at a plus 2h, f of a plus 3h at a plus 3h, and f of a plus nh at a plus nh respectively. क्रमशः. In Hindi you write respectively. Okay, क्रमशः. So if you see these are starting from, this could be written as, if you like, you could write a plus 0h. Okay, so starting from 0 we are going to n. So how many values are these? These are n plus 1 equidistant values. So these are n plus 1 equidistant values. Equidistant means at equal distance, like if I elaborate, the distance between a and a plus h is h, interval of differencing. A plus 2h is again 2h, and so on. So it is called equidistant values, and these are n plus 1 equidistant values. Okay, then we know that if f assumes n plus 1 value at n plus 1 point, so then fx can be a polynomial of degree at most equal to n. So for the sake of simplicity we assume, let us assume that fx is a polynomial of degree n and given by f of x is equal to a naught plus a1 x minus a plus a2 x minus a x minus a plus h. These are the smallest bracket. This is the smallest bracket. Okay, plus a3 x minus a x minus a plus h x minus a plus 2h, okay, plus and so on. It will be, last term will be an. Look over here, if here is 3, so it is 1 less than 3, it is running up to 2, 0, 1 and 2. So here will be if n, so it will be running up to 1 less, that is n minus 1. So it will be x minus a x minus a plus h x minus a plus 2h and so on, x minus a plus n minus 1 h, and you are going to name this equation as 1. And here you mention where a naught, a1, a2 up to an are constants to be determined, whose values is to be determined. Now first we calculate a naught. We are given that x at x is equal to a. So if you use x is equal to a, in this here will be f of x will be f of a. We are given it that at x is equal to a, f of x is f of a. So at x is equal to a, 1 will imply 1 implies this will be f of a is equal to a naught, and here you see here will be a minus a 0, a minus a 0, so all the rest of the terms will become 0. So this implies that a naught is equal to f of a. Fine, so this is the first value, and you are going to name it. If you want, you get to name it as 2. Next, at x is equal to a plus h, 1 will imply f of a plus h. Okay, fine. If you see here, it will be f of a plus h is equal to a naught plus a1 a plus h minus a plus, here if you see a plus h minus a plus h, this will become 0, this due to this will become 0, due to this will become 0, so all the terms will become 0. So I'm going to write it as the rest terms will become 0. This will cancel out. This implies that f of a plus h is equal to a naught from equation number 2 is f of a. So I'm going to use it as f of a plus h, and it is a1. This implies that f of a plus h minus f of a is equal to h. a1 implies a1 is equal to f of a plus h minus f of a divided by h. So here what we have done, we have taken it into left side, so this will become negative, and this is taken down. By the definition of forward difference operator, this will become, we are going into forward direction from f of a, so this will become forward difference operator of f of a by h. So this implies that a1 is equal to delta f of a by h. So this is the next value and name it as equation number 3. Now next, at x is equal to a plus h, at x is equal to a plus 2h, not a plus h, a plus 2h. Equation 1 will imply, it will be, look over here, here will be, it assume value a plus 2 f of a plus 2h, so you could directly write f of a plus 2h is equal to a naught plus a1 a plus 2h minus a plus a2 a plus 2h minus a plus 2h minus a minus h, and rest due to this one it will become 0, and due to this one it will become 0, so rest is 0. So here we have substituted a plus 2h, a plus 2h, a plus 2h, a plus 2h minus a plus 2h, minus will open, minus a minus h. So this further implies that f of a plus 2h is equal to a naught is f of a plus a1. This will cancel out, so we are left with 2h, plus this will cancel out, a2 2h, this will cancel out, so we are left with h. Okay, so this implies that f of a plus 2h is equal to f of a. What is the value of a1 from equation number 3? Delta of f of a by h plus 2 h square a2. Now this further implies that f of a plus 2h is equal to f of a, and h to h will cancel out. To use the definition of delta f of a, forward difference operator, it will be a plus h minus f of a plus 2 h square a2. This implies that f of a plus 2h is equal to f of a plus 2 f of a plus h minus 2 f of a plus 2 h square a2. This implies that f of a plus 2h is equal to, so this will be 2 f of a plus h, and you will see it will be minus f of a, so this will be minus f of a plus 2 h square a2. Now we will write this as f of a plus 2h, and this twice of f of a plus h is split into 2 f of a plus h minus f of a plus f of a plus h plus 2 h square a2. So this is split into 2, 1 f of a plus h, f of a plus h, and you know this is equal to delta f of a, this thing. Okay, this is delta f of a, and this will go from here to there, so this implies that f of a plus 2h minus f of a plus h plus 2 h square a2. So by definition of forward difference operator, a plus h to forward direction, so it will be delta f of a plus h is equal to delta f of a plus 2 h square a2. This implies that delta f of a plus h minus delta f of a is equal to 2 h square a2. This implies that delta square f of a is equal to 2 h square a2. So this further implies that you again use the definition of forward difference operator, forward from a to a plus h, forward from a, and forward of again first order will be second order, del square. So this delta square f of a by 2 h square is equal to a2, and 2 can be written as 2 factorial. So if you see that for a2 here is del square f of a 2 factorial h की 2, and for a1 delta 1 h1 and 1 factorial. It could be written as a1 delta f of a 1 factorial h की 1, and similarly a naught is f of a naught is f of a, which is nothing but 0 order forward operator, and it could be written 0 factorial and h की 0. So this will be again f of a. So whenever through generalization, when 1 is here is 1 and here is 1 factorial, when 2 is here 2 factorial h raised to power 2, when 3 will be here, if I write similarly a3 is equal to delta 3 f of a by 3 factorial h raised to power 3, and similarly continuing so on, means it will continue, and at the end an will be delta n f of a divided by n factorial h raised to the power n. So these are the values. Now substituting these values in equation number 1. So this is the equation number 1. So now I am going to put the values that I have calculated. So first f of x is equal to a naught was f of a plus x minus a, and a1 was delta f of a by h plus x minus a, x minus a plus h, and a2 was delta square f of a 2 factorial h square plus x minus a, x minus a plus h, x minus a plus 2h into delta cube f of a by 3 factorial h cube up to so on x minus a, x minus a plus h, x minus a plus 2h up to x minus a plus n minus 1 h, and it will be delta n f of a n factorial h raised to the power n. So this formula is called Newton's forward difference formula or Newton-Gregory forward difference formula. Okay, now this formula can also be written in terms of u, we know that u is given as x minus a by h. This implies that uh plus a is equal to x. So here it will be used, x will be replaced as a plus uh. Fine. Now x minus a, from here if you say it will be uh, so this implies that x minus a is equal to uh. So this value will be used over here. Next, this value is known. Now this value will be calculated. We are turning it into u as function of u. So x minus a plus h is to be determined. So this can be written as x minus a minus h. This will open minus a minus h. X minus a, this value is uh. Okay, so I'm going to put it as uh minus h is equal to u minus 1 h. Similarly, if we determine x minus a plus 2h, so what it will be? X minus a plus 2h. This will be x minus a minus 2h. Fine. And this can be written as x minus a minus h minus h. And this value x minus a minus h, x minus a minus h is u minus 1 h. So at this place I am going to put u minus 1 h, u minus 1 h minus h. So this will be u minus 1 h is equal to u minus 2 h. Now look over here, when here is x minus a plus h, h coefficient is 1, so here is u minus 1 h, h coefficient is 2, here is u minus 2 h. Similarly, when we calculate this one, so then what will happen? It will be h here, u minus h coefficient n minus u minus n minus 1. So if I write similarly x minus a plus n minus 1 h, this is equal to u minus n minus 1 h. Okay, or you can also write it as u minus n minus 1 smallest bracket and h, both have same meaning, Now substituting all these values in equation number, say if I name this equation as equation number 4, we will get if we put it over here, this will be put it over here, a plus hu. So using these values in equation 4, we get f of a plus hu is equal to f of a plus x minus a is delta f of a by h plus again u minus 1 h delta square f of a 2 factorial h square plus u minus 1 h into u minus 2 h into delta cube f of a by 3 factorial h cube up to so on u minus 1 h into u minus 2 h into up to u minus n minus 1 h delta n f of a divided by n factorial h raised to the power n. So if you see here, 1h to h will cancel out, so this will cancel out, these 2h will cancel out, there are 3, 1 2 3, this will cancel out, and here are 1 2 up to n, because here u minus 0 up to n minus 1 is n terms, so h raised to the power n here will be, so this will cancel out, so this will cancel out, okay, and this will also cancel out. So we are left with f of a plus hu is equal to f of a plus u by 1 factorial delta f of a plus u minus 1 by 2 factorial delta square f of a plus u minus 1 u minus 2 by 3 factorial delta cube f of a plus up to so on plus u minus 1 u minus 2 up to u minus n minus 1 divided by n factorial delta n f of a. So this is the value of the function. Fine, this is the function, and this in subscript notation, this could be written as f of a plus hu is equal to f of a plus u 1 by 1 factorial delta f of a plus u2 by 2 factorial delta square f of a plus u3 by 3 factorial delta 3 f of a and so on u n by n factorial delta n f of a, where you mention the meaning of u r is equal to u minus 1 u minus 2 up to 1 less u minus r minus 1. Fine, and r is ranging from 1 to n, so this is in terms of u, this is Newton's Gregory forward difference formula. So in the examination its proof could be asked, so you could do it up to here also if you write it in the compact form in terms of u. So this is superscript notation, this is superscript notation. Fine, so this is Newton Gregory forward interpolation formula. So if in the examination statement is asked, you will write that if x is lying near the beginning of the table, then the function f of x in terms of u is given by this one. So where x is lying near the table, x is lying near the beginning of the table. Fine. So the function fx is given by this one. You will write the statement if x is laying near the beginning of the table, then this formula you will write in the statement if statement is asked in the examination. Or you could also write if x is laying near the beginning of the table, then f of x is given by this one. You could also write this formula also. So this will be the statement. If in the examination it is asked that state and prove, then firstly you will state that if x is laying near the beginning of the table, okay, then this fx is given by this one. So that's all I have from this lecture, and in this lecture we have derived the Newton's forward difference formula, and this formula is very important from the examination point of view. So I expect you all to go through this one and practice it at your own. And this formula is important, and there is hardly any chance when this formula does not appear in the examination, either numerical or state and prove. This comes in the examination. So that's all I have from this lecture, and I hope you will be able to understand it. And very soon I will be again with you with my next video lecture. Till then, take care. Bye bye. See you soon.